Question number 4 taken from October 2014, Advanced Level Maths for HSC. The parametric equations of a curve are x is equal to 1 over cos cube of t and comma y is equal to tan cube of t, where 0 is less or equal to t, less or equal to half pi. Show that dy by dx is equal to sine t. Second part of the question is hence show that the equation of the tangent to the curve at the point with parameter t is y is equal to x sine t minus tan of t. Question carries 7 marks. Okay, how are we going to do the first part? How are we going to proceed? Now we know that x is equal to 1 over cos cube of t. So we're going to differentiate that, and then we also have y is equal to tan cube of t. So differentiating that, we're going to say this is quotient rule. U is equal to 1, v is equal to cos cube of t. So du by dt is equal to 0, and here we're going to say dv by dt is equal to 3 multiplied by the derivative of cos. So when we differentiate that, we're going to get, we take the 3, we'll make it the coefficient. It becomes minus because differentiating cos, you get minus sine. For minus sine t times cos square t. So v du by dx minus u dv by dx, but here it's v du by dt minus u dv by dt. It's going to give you dx by dt. Therefore dx by dt is equal to, this times this is going to give me 0 minus 3 times 1 is minus 3 sine t cos square t times 1 is minus 3 sine t cos square t, all divided by v square, and v is this. Therefore cos cube of t to the square. How is going to make it? What is going to make it? Minus minus becomes plus. So we have 3 sine of t times cos square of t, all divided by, what is this? 3 times 2 is 6. Cos cube of 6 power 6 plus 3 times 2 is 6 t. So cross this one out, there's 2 here, so you minus 2 here. So I'm supposed to say 3 sine of t sine t divided by cos power 4t. This is exactly the same as 3 sine of t over cos of t times 1 divided by cos cube t. Why? Because cos cube t times cos t is equal to cos power 4t. Therefore, what is sine upon cos is tan. 3 tan of t divided by 1 over cos cube of t. What is 1 over cos? 1 over cos is sec, therefore sec cube t. So this is dx over dt. We're going to move on to, what is this one? Y is equal to tan cube of t. For this one, we can say that let tan of t is equal to u. Therefore, y is going to be u to the cube. Differentiating here, dy by du, we get 3u square. And differentiating u, which is tan t, so du by dt is going to be sec square t. And so what is dy by dt? Dy by dt is dy by du multiplied by du over dt. So dy by du is 3u square. And what is u? U is tan t, so 3 tan square t. Okay, multiply by du over dt. Du over dt is sec square t. Sec square t. So we have to prove that dy by dx is equal to sine t. So how are we going to do this? What is dy by dx then? So dy by dx is equal to dy by dt multiply by divide. Well, you can divide, you can multiply, but if you multiply, you're going to say dt over dx. Therefore, what is dy by dt? And dy by dt is 3 tan squared t sec squared t multiply by dt over dx. But we know dx over dx over dt. We do the reverse. This is over 1. So you multiply. If you do the reverse, this is going to come down. So over here, you're going to put this divide by 3 tan of t sec cube of t. Right. So the 3 goes out. The tan goes out to -1. They remain with tan. You have tan of t. Then sec squared t over this -1 times 1 upon sec t. Okay, what is tan t? Is sine upon cos. Sine t over cos of t. Alright, multiply by, what is this? This is cos of t, isn't it? Cos of t. So this one goes out, and therefore we have then dy by dx is equal to sine of t. And so this has been shown. That's the first part of your question. For the second part, alright, we have to show that the equation of the tangent to the curve at the point with parameter t is y is equal to x sine t minus tan t. Okay, what information do we have? Alright, so the information we have is that we're going to take any point, which is x and y, and what is the second coordinate that we have? The second coordinate is x is equal to 1 over cos cube of t, and the other one is tan cube of t, and we have dy by dx, which is in fact the gradient, is equal to sine of t. So how do we find the equation of a straight line? Okay, it's y is equal to mx plus c basically. So we're going to say y minus this. So y minus tan cube of t is equal to the gradient that is which is sine of t multiplied by x minus this, x minus 1 upon cos cube of t. Alright, so perform the multiplication. You're going to go y is equal to sine, so x times sine t is x sine of t minus sine t times cos cube t is sine t upon cos cube t. This is minus here, sin on the other side becomes plus tan cube of t. Therefore y is equal to x sine of t, okay, minus, what is sine upon cos? It is tan t, divided by, because what is sine upon cos? You've taken 1 cos here, this was cube, so you remain with 1 upon cos square t, plus tan cube of t. So y is equal to x sine of t, alright, minus, what is common here? Tan and tan. So we're going to put tan outside, tan t outside. Inside we're left with 1 upon cos square t plus, be careful, because this becomes minus, minus times minus becomes plus here. So tan t is out, we have tan cube t there, so that becomes tan square t. From here, y is equal to x sine of t, alright, minus tan of t. It's up to you how to proceed, how you want to proceed. We can do cross multiplication. 1 times 1 is 1, minus tan square t times cos square t, tan square t, cos square t. 1 times cos square t is cos square t. So y is equal to x sine of t minus tan of t. In brackets, what do you have? 1 minus tan square t. What is tan square t? Tan square t is sine square t divided by cos square t. All of that being multiplied by cos square t, multiplied by cos square t, divided by cos square t. So y is equal to x sine of t minus tan of t in brackets. This 2 goes out. 1 minus sine square t is cos square t divided by cos square t. This goes out, becomes 1. Therefore you have y is equal to, you're left with y is equal to x sine of t. 1 times tan of t is minus tan t. So here we are. You've been able to prove it.